Hello and welcome. It is December 25th, 2025. While families across the globe are unwrapping gifts and settling in for holiday dinners, something else is unwrapping itself in the deep vacuum of space, a gift, or perhaps a warning, from the furthest reaches of the galaxy. Tonight, we are tracking a visitor that has traveled millions of years to reach our solar neighborhood, and its arrival coincides with a significant anniversary in human exploration. Exactly 4 years ago today, the James Webb Space Telescope launched, promising to unveil the universe's secrets. And tonight, as if on cue, the universe has answered back with 3I Atlas. This isn't just another rock. It is a hyperbolic anomaly, an interstellar traveler that is currently racing outward at a blistering 210,000 kilometers per hour. That's 130,000 miles per hour. To put that in perspective, it is moving fast enough to travel from New York to London in under 2 minutes. Right now, as we speak, 3I Atlas is positioned roughly 2.5 astronomical units from the Sun and 1.81 AU from Earth. It is piercing through the darkness en route to a rendezvous with Jupiter in early 2026. But what makes this Christmas encounter so transfixing isn't just the speed, it is the visual spectacle accompanying it. If you have a small telescope and clear dark skies tonight, look toward the constellation Leo near the bright star Regulus. You might see a faint, fuzzy smudge, but through the eyes of our most powerful optics, that smudge transforms into a vibrant emerald green apparition. This striking color is the result of diatomic carbon emissions, two carbon atoms bonded together, glowing under the bombardment of solar ultraviolet light. It is a chemical signature that screams active, telling us that this object is waking up as it feels the heat of our star. Before we go any deeper into the physics of this encounter, if you want to stay ahead of these breaking cosmic events and understand the science shaping our future, make sure to subscribe to the channel. We are tracking this trajectory in real time, and you won't want to miss the updates as we approach the Jupiter flyby. Now, let's look closer at the data coming in from ground-based observatories. The green hue is beautiful, yes, but it is also a diagnostic tool. It tells us that the comet is shedding volatiles, stripping away its outer layers to reveal the ancient material beneath. This is material that likely hasn't seen the light of a star since it was ejected from its home system eons ago. We are looking at a time capsule from another part of the Milky Way. But why is it here now? And why does its arrival feel so synchronized with the chaotic space weather we are experiencing? The timing is uncanny. As 3I Atlas cuts through the solar system, we are simultaneously weathering a massive geomagnetic storm. You might have seen the photos flooding social media, auroras painting the sky red and green as far south as mid-latitudes. This cosmic Christmas light show is stunning, but it is also disruptive. GPS signals are wavering. Power grids are seeing induced currents. Aviation routes are being diverted to avoid high radiation zones. We know the immediate cause, a strong X1.9 class solar flare that erupted on December 8th, followed by a series of coronal mass ejections. But here is the crucial detail that has some astrophysicists raising their eyebrows. The intensity of these storms seems to be persisting longer than our standard models predicted. This brings us to a controversial yet fascinating hypothesis emerging from the data. We are looking at a hyperbolic trajectory with an eccentricity of roughly 6.1. That is an extreme number. It confirms, without a doubt, that this object is not bound to our Sun. It is just passing through, but as it passes, it is dumping massive amounts of dust and gas into the interplanetary medium. We observed a 3 million kilometer jet system trailing this object even before it reached its closest point to the Sun. The question we have to ask is, could this interstellar injection of dust and volatiles be interacting with the solar wind in a way we haven't accounted for? Imagine the solar wind as a stream of charged particles flowing out from the Sun. Now, imagine throwing a handful of sand into a fan. The dust from 3I Atlas is that sand. It's a speculative fusion of astrophysics and space weather dynamics, but experts are now theorizing that the comet's massive dust ejection may be subtly perturbing the solar wind, perhaps even amplifying the geomagnetic disturbances we are feeling on Earth right now. It is a cosmic handshake, a physical interaction between a star and an interstellar visitor that might be modulating our magnetosphere. This contradicts what we previously thought about cometary impacts on space weather. We usually treat comets as passive observers, ghost-like wanderers that leave pretty trails but don't touch the machinery of the solar system. But 3I Atlas is massive, and it is active. If this theory holds, it means that the vibrant auroras you might be seeing out your window tonight are not just the result of the Sun's fury, but a complex interplay between our home star and a visitor from the deep void. It suggests that our solar system is not a closed loop. It is an open ecosystem, susceptible to the influence of passing strangers. The visual data supports this level of activity. The comet has brightened significantly in the last few weeks, far more than standard models for a dirty snowball would suggest. This brightening is what makes it visible near Regulus. It's not just reflecting sunlight, it is fluorescing, reacting, changing. And as we track it moving away from us, heading toward the outer solar system, we have to wonder what it is leaving behind. The dust trail it is laying down is a breadcrumb trail of organic chemistry, potentially seeding our zodiacal cloud with exotic compounds. So, what does this actually mean for us on the ground? It means that the Christmas star of 2025 is a dynamic, physical event. It is a reminder that we live in a busy, interactive galaxy. The disruption to our technology, the GPS glitches, the radio blackouts, are the friction sparks of this interaction. We are seeing the tangible effects of cosmic connectivity. And while the auroras are a delight for skywatchers, they are a headache for satellite operators who are trying to keep our modern world online. As we watch 3I Atlas fade from the naked eye and become a target solely for our telescopes, we must remember that its journey is far from over. It is racing toward a gravitational keyhole near Jupiter. But before it gets there, we need to understand the object itself. What is it made of? Why is it spinning the way it is? The initial light curves are confusing, showing a rhythm that doesn't quite make sense for a simple, solid rock. There is a heartbeat to this comet, a pulse that hints at a violent history. In the next chapter of this investigation, we are going to strip away the coma, that glowing green atmosphere, and look at the nucleus itself. New data from Gemini North and Subaru is painting a picture of something jagged, elongated, and strangely balanced. We are going to analyze the rotation period and the oscillating jets that are baffling the dynamics team. Because if 3i Atlas is a messenger, the message is written in its spin. As we established in our initial analysis, the emerald glow of 3i Atlas is merely the shroud covering the true mystery. To understand what this visitor really is, we have to look past the halo of diatomic carbon and focus on the solid heart beating within. This is where the story shifts from a visual spectacle to a forensic investigation of a galactic crime scene. We are no longer just looking at a comet. We are looking at a survivor. Real-time data streaming in from the Gemini North Telescope in Hawaii and the Subaru Telescope has allowed astronomers to peer through the gas and dust. What they have found is a nucleus that defies the simple, dirty snowball analogy we teach in school. The estimates for its size are currently bracketing between 0.4 and 5.6 kilometers wide. That is a massive range of uncertainty, and it points to a fundamental difficulty. The object is shrouded in its own exhaust, but by analyzing the way light reflects off the nucleus as it tumbles through space, we have derived a refined rotation period of 15.5 hours. This 15.5-hour day is the heartbeat of the comet, but it's not a steady rhythmic pulse. The light curve, the graph showing how the brightness changes over time, is messy. It's jagged. If 3i Atlas were a perfect sphere or even a simple potato shape, we would see a smooth, repeating wave. We don't. We see sharp peaks and deep troughs, indicating an object that is extremely elongated or perhaps contact binary, two objects stuck together. But here is the crucial detail that has the dynamics team scrambling. The jets are oscillating. Usually, when a comet heats up, jets of gas erupt from the surface like geysers. They tend to be relatively stable, pointing toward the sun, or erupting from a specific hotspot. But the jets on 3i Atlas are wobbling. They are precessing, like a spinning top that is about to fall over. This suggests that the internal structure of the comet is asymmetric. The mass isn't distributed evenly. There is a heavy side and a light side, a dense core and a porous crust. Let's look closer at the data regarding these jets. The oscillation pattern hints at internal structural asymmetries. This is scientific code for "this thing is a mess inside." Why is that important? Because it tells us about the environment where 3i Atlas was born. A nice, round, symmetrical comet is usually born in a quiet, orderly accretion disk. A jagged, lopsided, tumbling rock is a product of violence. This leads us to one of the most compelling theories currently circulating in the astrophysics community. 3i Atlas might be a remnant of an ancient galactic merger. We know that galaxies grow by eating each other. When two galaxies collide, the gravitational tidal forces can rip planetary systems apart, flinging trillions of comets and asteroids into the dark void between stars. The chaotic spin and the structural damage we are seeing on 3i Atlas could be the scars of such an event. It might have been torn from its home star billions of years ago, subjected to intense gravitational shearing, and then frozen in the deep freeze of interstellar space until it stumbled upon our sun. So, what does this actually mean for the object's integrity? If the rotation speeds up, a phenomenon known as the Yorp effect, where sunlight pushes on the irregular shape to spin it faster, the comet could tear itself apart. We are watching a structural stress test in real time. The 15.5-hour period is safe for now, but as it continues to outgas, that rate could change. If it spins up to, say, 12 hours or 10 hours, the centripetal force might overcome the weak gravity holding this rubble pile together. We could see 3I Atlas disintegrate before our eyes, turning from a single object into a swarm of interstellar shrapnel. This brings me to a question for you all in the comments. If this object does break apart, do you think we should try to capture a piece of it? Or is the risk of bringing interstellar material back to Earth too high? I want to hear your thoughts on the ethics of sampling these visitors. Drop a comment below. The possibility of disintegration adds a layer of urgency to our observations. Every night that Gemini North captures a spectrum, we are looking for signs of stress fractures. We are looking for outbursts, sudden brightenings that indicate a massive chunk of the surface has just blown off. And we have seen hints of this. The massive dust ejection we mentioned earlier, the one that created the 3 million kilometer tail, was likely a surface collapse event. A piece of the comet gave way, exposing fresh ice to the sunlight, causing an explosive sublimation that threw tons of dust into the wake. This dust is not just debris, it is data. The composition of the dust tells us the chemical recipe of the star system 3I Atlas came from, and the early spectral analysis is showing us something unexpected. We are seeing ratios of carbon to nitrogen that don't match the comets in our own solar system. This contradicts what we previously thought about the universality of cometary chemistry. It suggests that the primordial soup in other parts of the galaxy might have different ingredients than our own. As the comet races away from the Sun, the heat is diminishing, but the internal heat, the thermal lag, is still working its way through the nucleus. The green machine is still churning. But as we track this tumbling, venting ruin of a world, we have to consider its impact on the space around it. We've talked about the object itself, but what about the wake it leaves behind? We are sailing our planet through the exhaust of an alien engine. In the next part of our deep dive, we are going to explore the solar amplifier effect. We need to understand how a rock less than 6 kilometers wide could possibly influence the magnetic field of an entire planet. We are going to look at the physics of the interstellar injection and ask if the Christmas storms of 2025 are truly just a solar tantrum, or if 3I Atlas is poking the bear. Building on this image of a tumbling, venting nucleus, we arrive at the most provocative and debated aspect of the 3I Atlas encounter. We have established that the comet is shedding material, a massive trail of dust and gas stretching over 3 million kilometers. But space is big, and usually a comet's tail is just a wispy decoration in the void. However, the timing of this particular passage has forced experts to reconsider the relationship between a passing comet and the star it orbits. We are investigating the solar amplifier hypothesis. To understand this, we have to look at the environment 3I Atlas is traversing. It is not moving through empty space. It is moving through the heliosphere, the bubble of magnetic fields and charged particles created by our Sun. And right now, the Sun is angry. We are near the peak of solar cycle 26, and the star is volatile. On December 8th, we witnessed a massive X-1.9 class solar flare, a violent explosion that hurled a coronal mass ejection, CME, toward Earth. That event set the stage, but the geomagnetic storms that followed, the G3 level disturbances that are currently disrupting power grids and painting the sky with auroras, have persisted longer and with more intensity than the models predicted. Here is the crucial detail. The trajectory of 3I Atlas, with its extreme eccentricity of 6.1, cuts across the magnetic field lines of the solar wind at a steep angle. As it does, it is dumping tons of ionized gas and charged dust into the flow. Experts now theorize that this interstellar injection is acting like a catalyst. It's not that the comet is creating the storm, the sun did that, but the comet might be modifying the conductivity of the plasma, allowing the storm to couple more efficiently with Earth's magnetosphere. Think of it like salting a road. The ice is there, the solar storm, but adding salt, the cometary dust, changes the freezing point, changing how the ice behaves. In this case, the salt is exotic material from another star system, and it is changing the way the solar wind shocks against Earth's magnetic shield. This cosmic handshake is a terrifyingly beautiful concept. The volatiles from a frozen world interacting with the fire of our sun to modulate the weather of our planet. This contradicts what we previously thought about the scale of influence. We used to think comets were too small to matter. But 3I Atlas is proving that if you inject enough mass into a sensitive system at the right moment, the effects can be amplified. The data supports this. We are seeing elevated cosmic ray fluxes and atmospheric radiation levels spiking to 2-decade highs. This isn't just about pretty lights in the sky. This is about the radiation environment at cruising altitude for aircraft. It is about the error rates in satellite processors. The interstellar injection aligns eerily with the spike in solar activity. The timeline matches. The comet's pre-perihelion outburst, that massive jet system we discussed, occurred just as the solar wind density in that sector was increasing. It is a perfect storm of orbital mechanics and plasma physics, and the result is what we are seeing now, a cosmic Christmas light show that is delighting sky watchers but worrying infrastructure engineers. So, what does this actually mean for the next few months? If this amplification theory is correct, we might see continued geomagnetic instability even as the specific solar flare events fade. The dust trail is still there. The salt is still on the road. We could be looking at a period of enhanced auroral activity and radio disruptions that lasts well into early 2026. It challenges our predictive models, which are based solely on solar output. We now have to factor in the cometary variable. Bolder speculations are even suggesting that this interaction could influence terrestrial weather. There is a fringe but growing area of research looking at how cosmic rays and charged particles influence cloud nucleation, the formation of clouds. If 3I Atlas is modulating the cosmic ray flux reaching the atmosphere, could it be subtly tweaking our weather patterns? Could the enhanced lightning we are seeing in some regions be a downstream effect of this visitor? It is a speculative idea, and we must treat it as a question, not a fact. But the correlation is there, begging for investigation. The skepticism is healthy. Many solar physicists argue that the sun is capable of these tantrums all on its own, and that the comet is just a coincidence. They point to the natural variability of the solar cycle. But the coincidence argument is getting harder to maintain as we see the specific chemical fingerprints of the comet, like that diatomic carbon appearing in the spectral analysis of the solar wind stream. We are detecting the comet's breath in the wind that is hitting Earth. This fusion of astrophysics and space weather dynamics is rewriting the textbook. It suggests that the solar system is more interconnected than we realized. A visitor from light years away can, quite literally, change the magnetic weather on Earth. It makes the universe feel smaller, more intimate, and more dangerous. As we grapple with the physics of this interaction, another question looms, one that moves from the realm of natural forces to the realm of intelligence. The behavior of 3I Atlas, its speed, its rotation, its sudden brightening, has reignited the debate that started with Oumuamua. Is it just a rock? Or is the course change we are observing something more deliberate? In the next chapter, we are going to tackle the alien artifact debate head-on. We will look at the data from Breakthrough Listen, the search for technosignatures, and the social media storm that claims this isn't a comet at all, but a probe. We will separate the science fiction from the science fact. Given what we now understand about the comet's volatile nature and its interaction with the solar wind, we must address the elephant in the room, or rather, the starship in the solar system. Ever since Oumuamua tumbled through our neighborhood in 2017, the arrival of any hyperbolic object triggers a specific question. Is it artificial? With 3I Atlas, the internet is ablaze with theories that this is not a natural visitor, but a probe. And while skepticism is the default stance of science, we have to ask, is there any data to support the alien artifact hypothesis? The fuel for this fire comes from the trajectory data. 3I Atlas is exhibiting non-gravitational acceleration. In plain English, it is deviating from the path that gravity alone would dictate. It is speeding up. To the conspiracy theorist, this looks like an engine burn. It looks like a course correction. Social media platforms, particularly X, are flooded with posts analyzing these course changes, debunking the official narrative of natural outgassing and claiming that the object is maneuvering. So, let's look closer at the data. Is it an engine? The answer lies in the green hue we discussed in Chapter 1. The diatomic carbon emissions and the massive dust tail are the smoking gun, not of technology, but of chemistry. The non-gravitational acceleration is almost certainly caused by the rocket effect of outgassing. As the sun heats the nucleus, jets of gas shoot out. For every action, there is an equal and opposite reaction. These jets push the comet, altering its speed and direction. It is a natural engine powered by sunlight and frozen gas. However, the alien theory persists because of the nature of the outgassing. Remember the oscillating jets? The wobble? It makes the acceleration unpredictable. It mimics a controlled flight path to the untrained eye. But the randomness is the key. A probe would likely move with purpose. 3I Atlas moves with chaos. To settle the debate, we turn to the experts in listening. On December 19th, the Breakthrough Listen Initiative, the most comprehensive search for extraterrestrial intelligence, SETI in history, trained its radio ears on 3I Atlas. They used the Green Bank telescope to scan for technosignatures, narrow-band radio signals that nature cannot produce. They listened for a carrier wave, a beacon, a ping from the visitor. The results? Silence. The scan detected no technosignatures. The gigahertz silence is profound. If 3I Atlas is a probe, it is running in stealth mode. It is not broadcasting telemetry back to its creators. It is not hailing us. It is dead silent. This contradicts what we previously thought might happen if we ever encountered a probe. We assumed there would be a signal, but the silence itself is data. It forces us to conclude that, with high probability, 3I Atlas is a rock. A fascinating, active, dangerous rock, but a rock nonetheless. The cosmic handshake is chemical, not communicative. But the intrigue doesn't die with the radio silence. The alien artifact debate serves a purpose. It forces us to look harder. It drove the observation campaigns that discovered the rotation period. It pushed us to analyze the spectra with higher precision. Even if the answer is no, the question drives the science forward, and there is a lingering what if that keeps the astronomers awake at night. What if the probe is dormant? What if it is triggered not by proximity to the sun, but by something else? The hidden signal might not be in radio waves. It might be in the trajectory itself. Some researchers argue that we should look for gravity assists that don't make sense. Does the object use Jupiter to slingshot to a specific destination? We will find out in early 2026. The upcoming Jupiter flyby is the next critical test. If 3I Atlas performs a maneuver that defies the physics of outgassing and gravity, then, and only then, can we reopen the aliens file. For now, the signal in the noise is the noise itself, the hiss of gas, the crackle of dust impacts, the roar of the solar wind. The social media buzz-fueling alien probe theories underscores a deep human desire. We don't want to be alone. We want the visitor to be a messenger, but perhaps the message is simply that the universe is vast, messy, and full of debris from other worlds. As we move past the "is it aliens" question, we have to look at the broader context. 3I Atlas is not an isolated event. It is part of a trend. The Vera C. Rubin Observatory is coming online, and it is tracking over 50 more interstellar candidates. We are entering an era where these visitors will be common. 3I Atlas is just the first of a new class of objects that will reshape our understanding of cosmic connectivity. In our final chapter, we will look at the legacy of this encounter. We will project forward to the Jupiter flyby and the cosmic verdict. We will discuss how this comet fits into the headlines of SpaceX and Blue Origin, and what it means for the future of human space exploration. The story is only beginning. As the auroras fade and the holiday season of 2025 draws to a close, 3I Atlas continues its silent tumbling journey outward. It is leaving the warmth of the inner solar system, heading for the cold, crushing gravity of the king of planets. The Jupiter flyby in early 2026 is the final act of this immediate drama, but the legacy of this visitor will endure long after it has vanished into the dark. The encounter with Jupiter is not just a farewell, it is a gravitational experiment. Jupiter is the vacuum cleaner of the solar system. its massive gravity will constantly reshaping the orbits of everything that comes near it. As 3I Atlas threads the needle past the gas giant, its trajectory will be bent, twisted, and flung outward with even greater speed. This Jupiter slingshot will be the final confirmation of its interstellar nature. It will gain enough energy to ensure it never returns. It is a one-way ticket. But while 3I Atlas is leaving, it has opened a door. This event marks a turning point in astronomy. We are no longer waiting decades for the next interstellar object. The Vera C. Rubin Observatory, now fully operational, is tracking over 50 more interstellar candidates. We are realizing that our solar system is not a lonely island. It is a busy intersection. 3I Atlas may herald a new era of galactic visitors, reshaping our understanding of cosmic connectivity. It is the scout for a legion of drifters. This shift in perspective comes at a time when humanity is reaching outward with renewed vigor. The headlines are crowded with milestones. SpaceX has just celebrated its 300th orbital launch, a testament to the routine access to space we now enjoy. Blue Origin is prepping for an impending crewed flight that promises to push the boundaries of commercial space travel. And the James Webb Space Telescope, on its 4th anniversary, continues to peel back the layers of the universe, revealing exoplanet atmospheres that might host life. In this context, 3I Atlas is a mirror. It reflects our own growing capabilities. 10 years ago, we might have missed it. 20 years ago, we certainly wouldn't have had the spectroscopic tools to analyze its green heart or the interstellar injection into the solar wind. We are catching these visitors because we are finally looking with the right eyes. So, what does this actually mean for the future? It means that 2026 is going to be a year of revelations. As we analyze the data from the Jupiter flyby, we might find the final piece of the puzzle regarding the comet's origin. Was it a shard of a destroyed Earth-like planet? A fragment of a carbon star? The cosmic verdict is still out. But perhaps the most profound impact is the cosmic handshake we discussed earlier. The idea that a passing rock can touch our star and change our weather, even slightly, reminds us of our fragility. It reminds us that we are part of a galactic ecosystem. The interstellar injection of dust is a physical link between us and the rest of the Milky Way. We have breathed the air of another star system, processed through the solar wind. As we watch the comet fade, one thing is clear. In the vast interstellar tapestry, Earth's encounter with 3 Atlas is merely the opening chapter. It has whispered secrets of other worlds while subtly imprinting our own. The story is only beginning. The data we have harvested will be studied for decades. The questions it raised about alien probes, about solar dynamics, about galactic mergers, will drive the next generation of missions. If you enjoyed this deep dive into the science of the unknown, and if you want to support content that prioritizes data over hype, please hit the like button. It helps the algorithm find other curious minds like yours. And keep your eyes on the skies in 2026. The universe is getting crowded, and we are just starting to meet the neighbors.